Welcome to this on-demand webinar. My name is Chantal Julien. I am Global Product Manager responsible for quaternary ammonium compounds at Novo Nordisk Pharmatech. Today I would like to discuss the importance of choosing an antimicrobial ingredient for pharmaceutical formulations, and I will be focusing on benzalkonium chloride. When choosing an antimicrobial ingredient for your formulation, you will probably already know if it's for use as an active ingredient or as an excipient, as a preservative. If it is as an active ingredient, you would probably have to follow local GMP guidelines and source a GMP quality ingredient. You would be needing several pieces of documentation, such as probably a drug master file, statements, certificates, questionnaires, and so on. And of course, you would be looking for compendial compliance, if available, for example, to the European, the American, the Japanese pharmacopoeia, and preferably also compliance both to pharmaceutical monographs and general notices and general chapters. It is very similar for excipients. However, it is not all countries that require that you follow GMP guidelines for excipients. But you can at least get some inspiration from the IPEC guidelines or the EXIPAC guidelines. It is preferable, based on a risk-based assessment, to source a GMP manufactured excipient, again, if available, or at least in a quality that is acceptable for pharmaceutical use. And then you would probably be looking for a broad range active ingredient that is also simple, robust, and preferably cost-effective. Then there are also many other aspects that you can look at. And if we look, for example, first of all, at the ingredient itself, of course you want it to be efficacious. You will have to evaluate if you are looking for a broad spectrum active ingredient or if you want to focus on one specific microorganism, and that would be most relevant for use as an API, for example. Then you also want it to be safe, and you want it to be in a quality complying for pharmaceutical use. Then you can look at your supplier. You want to look at the supply chain safety, for example. You want to ensure that you have an excellent communication with your supplier, both under the qualification period, but also after you have purchased the product. Ensure that you get information on changes in documentation or processes, and changes affecting the quality of the product. And of course, you want to be able to audit your supplier. When looking at your finished drug formulation, you would consider the therapeutic area. You would consider the route of administration and also the type of delivery system, if it's, for example, for multi-dose use or single dose. Then why would you choose benzalkonium chloride as an antimicrobial for your pharmaceutical formulation? Well, benzalkonium chloride has been around for a while. It is a very well-known molecule. Already back in the 1940s, it was reported for use as a preservative in ophthalmic solutions. It is very well documented. Its effect, antimicrobial effect, is very well documented in several scientific papers. It is a very stable molecule. It is very resistant to several temperature and humidity conditions. And we have tested, of course, the product according to ICHQ1 stability guidelines and also under all available climatic conditions, and the molecule is proving to be very, very stable. It is also effective throughout a very wide pH range. So we are talking about 4 to 10 or even 11 in terms of pH range. And I will come back to pH later on during this webinar. Then also the molecule is a surfactant. It is a cationic surfactant, so it is positively charged and it is attracted to surfaces, which gives it several nice properties in terms of if you want to prepare a topical formulation, it can help it stick to the skin, for example, or the mucosa. If we look at the benzalkonium chloride molecule, which is quite a simple molecule, you have a chloride ion, you have a benzyl ring, and you have the nitrogen atom with methyl groups and also a long alkyl chain, oily alkyl chain attached to it. Standard benzalkonium chloride for pharma use normally will have a mix of 12 and 14 carbons in the alkyl chain length. Again, the molecule is positively charged, and this charge is not affected by environmental conditions. Also, another interesting property of the molecule is that it has a hydrophilic and a hydrophobic part, which can be used, for example, in formulations, oil in water formulations that can help keep an emulsion together. So the mode of action of benzalkonium chloride is very much related to the molecular structure. So the molecule is positively charged and therefore it is attracted to negatively charged surfaces. And it can be the skin, mucosa, hair, or also microbial membranes. So it attaches very strongly to microbial membranes, and then the oily alkyl chain length, which has a structure that resembles the lipid structure within the microbial membrane, will penetrate it and create openings and destabilize the structure of the microbial membrane. And then this will, in the end, cause death of the microorganism. There are also other mechanisms involved, but this is the main mechanism behind the effect of benzalkonium chloride in killing microorganisms. In terms of antimicrobial efficacy, again, the antimicrobial efficacy of benzalkonium chloride is very well documented in scientific papers. Nevertheless, we wanted to have our own test performed to verify the efficacy of our own product. Therefore, we commissioned the Danish Serum Institute to test benzalkonium chloride against gram-positive, gram-negative bacteria and yeast. So we chose a range of microorganisms that are part of standard pharmacopoeial testing for antimicrobial efficacy. So we included, for example, Candida albicans, Staphylococcus aureus, also including a multi-resistant strain, and Pseudomonas aeruginosa. So here benzalkonium chloride was tested against ethanol and against a positive control with an antibiotic. And what we could observe in terms of minimal inhibitory concentrations was that extremely low concentrations of benzalkonium chloride were necessary to control these microorganisms. Also compared with ethanol, where much higher concentrations were required. Slightly higher concentrations can be required to control Pseudomonas aeruginosa. And this is quite well known and well documented. You can choose to either use higher concentrations of benzalkonium chloride, or you can choose to use benzalkonium chloride in combination with chelating agents, for example EDTA, that would act synergistically and increase the effect of benzalkonium chloride against microorganisms. So is benzalkonium chloride also effective against viruses? As mentioned, yes, against enveloped viruses. So this is because of the mode of action of benzalkonium chloride. It requires a membrane to be effective. So it would not be effective against non-enveloped viruses. Examples of enveloped viruses can be adenoviruses, herpes, HIV, SARS-CoV, hepatitis A and B, for example, to name a few. So benzalkonium chloride is effective indeed against these microorganisms. We have performed a very comprehensive literature review to support this, and we have also published a white paper on this topic that we can make available for you. In this literature review, we also observed that concentrations of BKC of 0.5% or even less were sufficient to control these microorganisms. An interesting fact to mention as well is that benzalkonium chloride is a recognized, efficient antimicrobial effective against COVID virus. And this is recognized by several national agencies, such as the US FDA, the EPA, or the Canadian health authorities. So this is very relevant for topical applications, such as antiseptic solutions and creams, but benzalkonium chloride is also used in several other applications. Yes, benzalkonium chloride is used in a very wide range of applications, very often as a preservative, as an excipient in ophthalmic or nasal solutions. There it is very well known as a preservative. As an API, you would often find it in creams against psoriasis, herpes, acne, eczema. You would also find it in nappy rash creams. You find it in wound disinfection solutions for clinical disinfection, pre-operative surgery, and so on. You also find it in oral products such as throat lozenges, also products to treat cold sores, gum problems, gum pain, and so on. Benzalkonium chloride is also a spermicide, so you can also find it as an API in spermicidal gels or creams, and there it would have a dual effect as well, having an effect against HIV virus, for example, where it would also have an antimicrobial effect. And this goes for both human and veterinary drugs. So the pH of the final pharmaceutical formulation is important because pH can affect the growth of microorganisms. It can also affect the interaction of a preservative with cell wall components, and in the end also the inhibitory effect of the preservative. Microorganisms grow best at physiological pH between 6 and 8. Then if it is possible for you to prepare a formulation outside this pH range, this might help control microbial growth. However, it would not replace the use of a preservative in the formulation. Benzalkonium chloride is effective at a very wide pH range, as mentioned, between 4 and 10. So if you wish to if your formulation has a pH outside the pH range of 6 to 8, you still want a preservative such as BKC to be effective within these pH ranges. Then additionally, benzalkonium chloride is even more effective at higher pH because this affects the cell wall components and make microbial cell walls even more negatively charged, which helps binding of the benzalkonium chloride to the membranes. Therefore, if your formulation is at very high pH, you might consider using a lower concentration of benzalkonium chloride as a preservative. So the topics we discussed today were important aspects in choosing an antimicrobial ingredient for pharmaceutical formulations. We took a closer look at benzalkonium chloride as an antimicrobial ingredient, the molecule and its mode of action. And we also touched base on pH and its importance in pharmaceutical formulations. I hope you enjoyed these contents. We thank you very much for watching, and please do contact us if you have questions.